Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible. Structural analysis, truss analysis, zero force member. Zero force members. Our analysis can be greatly simplified if one can identify those members that support no loads. We call these zero force members. These members can use to increase the stability of the truss during construction and to provide support if the applied loading is changed. Rule 1. If only two members form a truss joint and no external load or support reaction is applied to the joint, the members must be a zero force member. Rule 2. If three members form a truss joint for which two of the members are collinear, the third member is a zero force member provided no external force or support reaction is applied to the joint. If a joint has only two non-collinear members and there is no external load or support reaction at that joint, then those two members are zero force members. In this example, members DEDCAF and A bear zero force members. Zero force members can be removed, as shown in the figure, when analyzing the truss. If three members form a truss joint for which two of the members are collinear and there is no external load or reaction at that joint, then the third non-collinear member is a zero force member, e.g. DA. Again, this can easily be proven. One can also remove the zero force member, as shown on the left, for analyzing the truss further. Please note that zero force members are used to increase stability and rigidity of the truss, and to provide support for various different loading conditions. What are zero force members? When analyzing trusses, we may come across members that carry no force. These are called zero force member. Member C carries no force. It is called a zero force members. Why are the zero force members in the truss? If a truss member does not carry any force, why have it in the first place? There are two main reasons for encountering zero force members in trusses. 1. A zero force member acts as a bracing for preventing a force-carrying compression member from buckling. That is a zero force member and stability to the structure. 2. A force having a magnitude of 0 could develop in a member at some point in time, when the structure is subjected to a time-variant load. Let us examine this scenario in more detail. Bridges structures are generally designed to withstand the load of moving vehicle where the load position changes as a vehicle moves across the bridge. Suppose we have a truss bridge consisting of 5 joints along its bottom chord. As a vehicle starts traveling on the bridge, the applied load's positions changes. At time t1, the load is distributed between joint 1A and D2. At time t2, the load is distributed between joint 2A and D3. At time t3, the load is distributed between joint 3A and D4. And so, this moving load pattern continues until the vehicle leaves the bridges. Bridge truss must be analyzed under each loading case. A truss member that actually carries an axial force in one loading case may become a zero-force member in another loading case. Example: when the load is applied at joint 1 and 2, see figure, the vertical member attached to joint 4 carries no internal forces. When the applied load moves to joint 3 and 4, the vertical member attached to joint 2 becomes a zero-force member. The ability to identify zero-force members in trusses is important for two reasons. It speeds up the overall analysis of the truss. It helps in developing a better understanding of how internal forces is distributed in structure. How to identify zero-force members in a truss. There are 3 basic rules for identifying zero-force members without resolving to any calculation. If a truss joint is not subjected to any applied load and is not supported by a pin or roller, then following rules can be applied repeatedly to all the zero-force members. If a truss joint is not carrying any loads and not supported by a pin or roller. Rule 1: if the joint connects to members only where the angle between the members is different than 180 degrees, both members are zero-force members. A band A care zero-force members. If this structure F connects to members only, there is no loads or supports at the joint. Therefore, both F and C are zero-force members. Rule 2: if the joint connects two members only and the members are collinear, that is, the angle between them is 180 degrees. And one of the members carries no internal force, the other one is also a zero-force member. If A carries no force, then A is a zero-force member. Consider the two members A band BC. If the force in member AB is 0, since he member are collinear, B is also a zero-force member. Rule 3: if a joint connects 3 members only and 2 of them are collinear, then the third one is a zero-force members. A dis as zero-force member, see figure. Here, joint D connects 3 members, 2 of the members are collinear, therefore C dis a zero-force member. Now, let us consider few examples. Example: first we will draw free body diagram. No load at D, no support at D. The angle is not 180 degrees. Here, we apply Rule 1 to joint D, therefore, CD and DE are zero force member. Rule 3 is applied to joint H, hence BH is a zero force members. No loads at H, no supports at H. Two of the members are collinear. Therefore, B is a zero force member. If we consider P to be an axial force in a member vertically attached to joint D, then according to Rule 3 E is a zero force member. According to the Rule 3 at joint E, E is a zero force member. Similarly, if we assume G is the force in an actual member horizontally attached to joint G, then according to Rule 3 AG is as rho force member. Rule 3 at joint G, AG is as rho force member. To determine the force in each of the remaining members, the simplified truss can be analyzed using the method of joints. Let us consider another example. See the truss member. Draw the free body diagram for the truss. In this example, Rule 3 is applied to joints C, B, E, and D. In that sequence. Therefore, BC, BE, DE and DG are the zero force members. Exercise questions. Try to solve the following examples. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.